Hi, welcome to RAR Math. Today I'm doing a series of videos on exponential and linear application problems. This one talks about the number of leaves on a tree just decreasing drastically over the month of November. Let's see, we start on November 1st with 500,000 leaves, and on the 30th we have 2,500. And we want the daily decay factor. So we have an initial and a final. The initial is 500,000. We want to know what we multiply that by to get down to 2,500. If we divide by 500,000, we get that A is equal to 0.005. But that, November 1st to 30th, that's actually 29 days. So we want to go from 29 days down to 1 day. So what we need to do is we need to take 0.005 to the power of 1 over 29, because we need to make sure we are doing a fraction of the multiplication factor. This gives us 0.833. So our model, leaves per day, is 500,000 times 0.833 to the D. All right, step 2, how many leaves will there be on December 5th? Well, to get from the days in November, from the 1st to the 30th, is 29 days. And then December 1, 2, 3, 4, and 5 is an additional 5 days. So we want to know 34 days from our initial. So leaves after 34 days is 500,000 times 0.833 to the 34. And we get 1,002 leaves on December 5th. Then it says, predict when the last leaf will fall. So because this is exponential and we can't equal 0 because exponents cannot make a number 0, we're going to use the number 1. We want to know when is 500,000 times 0.833 to the D equal to 1. Well, I start by dividing by 500,000. And when I do this, my calculator, not all calculators will do this, is going to give me 2 times 10 to the negative 6. That's the same as 0.000002. I'm going to keep it written exponentially. I'm just going to leave that number in the calculator. You can do that too, because our next calculation is that we do will involve this number, so you don't even have to clear your calculator regardless of how they give you it. You might get 2e negative 6. There's lots of ways your calculator will give you this funky number. Calculators love scientific notation. Okay, so to solve this, I need to take the log of both sides. The log of this side and the log of this side. And the beauty of logs is it makes an exponent a real number. The power rule says that this D can come out front and multiply, so that I have D times log of 0.833 is equal to log of 2 times 6 to the negative 6. Well, then I divide by log of 0.833 on both sides. And I get D is equal to 72 days. So we have 29 days in November, 31 days in December, 12 days in January. So on January 12th, the last leaf will fall. We don't need to get that specific. We can say 72 days, unless your instructor says, give a precise date. This for me would be good enough. Okay. But what if this was linear? And it says the number of leaves, we have the same numbers. We have the fact that on November 1st, there were 500,000 leaves, and on November 30th, there were 2,500. What if this is a linear? So M is equal to 2,500 minus 500,000 divided by 30 minus 1, and we get a slope of negative 17,155. All right. So leaves per day is going to be this 500,000 minus 17,155 D. I could have written it negative 17,155 D plus 500,000. It doesn't really matter. They're both linear models. Okay, How many leaves will there be on December 5th? Once again, 29 days of November, 5 days of December, 34 days later. In this model, number of leaves after 34 days is equal to 500,000 minus 17,155 times 34, which is going to be negative 83.3 leaves. That doesn't quite make sense unless the leaves are going to start floating back up. So when will the last leaf fall? So if I say 0, because there's 0 leaves left, we can do 0 with a linear. Minus 1755D. I'm going to add this over, so 17,155D is equal to 500,000. How many days at 17,155 loss until we've lost all 500,000? Divide by 17,155. And we get that the number of days is 29. And that makes sense, because if we're losing 17,000 a day and we have under 3,000 left, that means sometime on that 30th, 29 days later, sometime during the day, later on after we did our count, the last leaf will fall. So some time late on November 30th. Great. I hope you've enjoyed this video and the comparison of exponential versus linear. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!